Tēnā koutou katoa no Aotearoa o Tamaki Makaurau aho, ko Raafey tako ingoa, tēnā koutou, tēnā koutou, tēnā koutou katoa. Thanks for coming along, everyone. This is my third year in a row now talking at OWASP ANZ. I'm living in Brisbane now, but Auckland is very much my hometown, so great to be here. Already started talking about myself, but I lead the application security team at CyberCX. Mostly that's talking to security people to convince them that, security should be part of the development process, and then helping development teams to write and develop and deploy secure code and applications. Why am I here today? Number one, if you get anything out of this talk, really, I just want you to take away that OWASP is awesome. They're really good. There's a ton of resources out there. I'm going to go through a bunch of them today, but this is very much hopefully it'll get the thinking flowing, and you'll go away and you'll research other parts of it, and you'll find what's important to you. One of the things is there's too many things out there. OWASP alone has over 100 projects which you can use to secure your applications. It's kind of just overwhelming if you're getting started. So in this one, we'll go through some of the ones that I really like or I found and I think are cool, and then we can work through them. Second one, this is a little bit of a dig on ISO and general cybersecurity frameworks. They often tell you what you should do, but they don't really explain to you why you should do them or how you should do them. Now, I get that, everyone can't use the exact same patterns. But this is a problem that I've seen with a lot of the clients that I work with. So I wanted to kind of get a baseline of, this is how you do the things. And then the last point, everyone seems to be doing DevSecOps now. It's become a real buzzword. And, basically all of my targeted ads, including my personal devices, now have, every single tech company claiming that they do DevSecOps. Probably some vendors that shouldn't be claiming that. So, I kind of want to take away the fuzz around it all and just say these are the things that we should be doing. So, before I kind of submitted this talk, I started thinking about okay, what do I actually want to do? First thing is let's just define all of the tools and processes that we need. Obviously, OWASP was a great resource, so that was a starting point. And then I started building on that as I kind of, got deeper into it. Went down several rabbit holes, that kind of thing. So then the second thing I wanted to do was, all right, now we've got all the processes and all the tools that we want. Let's find OWASP projects to fit into each of these categories and see if it works. If I can't find an OWASP project, I'll find a project that's endorsed by OWASP. And then if both of those fail, then we'll go open source and just see what's out there, what's available. If open source fails as well, we'll go for the free options. And then this is going to come later on. Basically, let's see if we can build an entire application security program for a reasonably sized organization without spending any money on any vendors. This is, let's see how I go. Maybe next year I'll come back and talk to you about how that all went down. So number one thing to do is let's define all of the tools and all of the processes. What is a secure SDLC program look like? So this slide, it's going to get very busy very quickly, but essentially these are the development processes. We want some governance across the top. We want to design things, we want to build them, then deploy them, verify them, and then monitor them. Now, if we add all of the security things into here in one go, obviously, this is just a model. All models are wrong, some are useful, all of that kind of thing. I've made at least 5 iterations on this one model alone over the last few, days, years, however long I've worked on it. I won't spend too much time talking through all of this right now because we're going to start going through it in detail, figuring out what OWASP tools we can use, where, et cetera, et cetera. So across the top first, we've got our govern field. So what do we want to do in governance? We want to define some sort of a strategy, what are we actually trying to do here? We want to define our policies and processes, what are the processes people will follow? And we want to train everyone because I'm sure multiple talks at this conference have talked about the importance of training the people that will be doing this. That's why you're all here, to learn more things as well. That's key. All right, so number one, strategy. OWASP SAMM, I spent an entire day talking about this on Tuesday, but basically what is a strategy? It's where we are now, where do we want to be in the future, what are the things we're going to do to get there? I think OWASP SAMM is by far the best way to do this if you're looking at developer security. It is very prescriptive. If you have looked at the SAMM already, you'll have noticed that a bunch of these things over here have been taken directly out of SAMM, and then I've kind of gone into my own kind of rabbit holes. Now, we want to define the policies and the processes, the OWASP cheat sheets. I think there's about 50 of them now for anything that you could possibly want to do, from threat modeling to session management to secrets. Everything that you want to do is there. So this should really be the starting point if you're trying to define how your organization should do a particular thing. Use the cheat sheet, modify it as you see fit, and then over time it'll evolve. There's also the OWASP Secure Coding Practices Quick Reference Guide, which again, great resource from OWASP. You can use it to start defining those top-level policies and processes that you want. Then obviously, super key is the training aspect. Now, there is a ton of resources online just from everywhere that you can run a full training program in-house without really spending any money. The top one there is the OWASP, again, Security Champions Playbook, which will talk you through the step-by-step guide of what you need to do if you want to build a successful Security Champions program. So I feel like that should always be the cornerstone if you're going to implement something like that, or if you want to evolve how your Champions program is going, start using this. Secure Flag, although it is not like an OWASP project, if you have OWASP membership, which I believe still costs about $50 a year, you get access to a bunch of free labs within that platform. They've kind of partnered with OWASP for this. So generally the recommendation I make is if you're looking to train all of your developers and you want to give them online lab access, instead of buying a really expensive tool, just get them all OWASP membership. They'll get a bunch of access to labs, and then you're supporting the community as well, side by side. A couple of things on the side there, the Juice Shop, which I'm a big fan of. We use this in the training that we deliver as well. It's basically just a really bad vulnerable application. It's got a bunch of flags in it that you can find. It's pretty easy to get spun up and running, and people can kind of just attack it, see what's going on. And then nice little mention to Cornucopia, which is a card game. I'm going to talk about that more in the next phase. All right, now we have set up the governance. We've started training our people. Okay, we want to build something. So what do we want to do here? Really, we want to define the requirements of the application. So threat modeling, big advocate of that. Basically getting everyone in a room, figuring out, okay, we're building this, what can go wrong with this? We need to let users upload files to our application. What happens if they upload something that's 100 terabytes? What happens if they just throw some malware there? What can go wrong? What controls do we need? So for that, we've got multiple options, both from OWASP. We've got Threat Dragon, which in the last about 6 months or so got some really good feature updates. It just allows you to map out your architecture, map out your process flows, and start thinking about what can go wrong with this. If you prefer a more code-focused approach, there's PyTM, which basically just allows you to document all of the threats as code using this Python application. And then Cornucopia comes back again because it's a card game which you can play and helps you think about the threats to your applications. Makes it a little bit more fun. So now we've figured out all of the things that can go wrong. We also want to define those baseline security requirements, like what should our app just do by default, because it's really important. So again, we have two guides here. The ASVS, the Application Verification Security Standard, and the MASVS, same thing, but for mobile applications. This one, basically, you can select a level. How critical or risky is the application you're building? 1, 2, and 3. Define that, figure out which of the key areas are in scope, and suddenly you have this big, long list of all of the security requirements that your application should implement. Now, we have successfully started to think about what are we going to build. We're going to start coding it and actually getting it to work. So we move into the build phase. Now here, so once the code is written, we want to start thinking about, okay, how are we going to review this, figure out what's going wrong. So in the last phase, we use the ASVS to define the requirements. Now we're going to use the security testing guide and the mobile application security testing guide to take all of those requirements that we defined and then figure out like what test cases we need to build to actually see if we've met them or not. So we've defined it, now we're going to test it. Luckily, OWASP kind of provides you both sides of that coin. As we're building the application, we're going to run into all sorts of issues with our secrets, like where are we going to put them? So we have the secrets management cheat sheet, which will tell us like how we should actually manage the secrets. And if you're using something like a GitHub, GitLab, Jenkins, there's usually a secrets manager built in. But if you want to use something external, there is also Confident, which was built by the dev team at Lyft. And it's not an OWASP project, that's why it's got a little asterisk. That's started popping up a little bit now. But it is fully open source, so you can kind of go use that and test out, do we actually need one of these commercial solutions in the future? Now, we have written the code, so we want to start testing it all. OWASP has this great, massive list of every single source code analysis tool that exists, I think. It continually gets updated. Last time I checked, there was about 100 or so of them on there. So whatever language you're programming, go on there, hit Control F, you'll find an open source scanner for that. Some of the favorites, SAMM is not OWASP, but fully open source. They have moved to a commercial model as well, but their open source local scanner is still available for free. We'll scan basically every language from a static analysis viewpoint. And for the code quality bit, making sure that we're actually building efficient algorithms and things like that, it's really hard to just look past SonarQube, no matter where you go. There is a community edition of Sonar, which is free. Again, if you're going to start getting bigger and bigger, you can go for the commercial models. But as a starting point, this kind of stack is fantastic just to get things built in. When we start looking at the third-party dependencies we have, like dependency check and dependency track, if you want to find out more about them, in the front did a talk yesterday on both of these tools. Either watch that or just go bug him. All right, now we have built an application. So we're going to move into actually deploying this app. What should we be doing in that phase? So again, this is the third tier. Really, there's a few different things that we need to think about. A lot of the security that we added in the build and design phase, or that I put in that area, was really focused about security within the pipeline, making sure that the code that we're building is secure. But there's also, there's one of the key things is making sure that we're actually building a secure pipeline itself. So very recently, I think it was this year actually, OWASP came out with the top 10 CI/CD security risks to match the other, OWASP top 10 lists. It's quite good, it's prescriptive. You can go through that and figure out, okay, what could go wrong in the CI/CD platforms that we're actually using. Another really good framework that I've started to use a lot more recently is called the SALSA. I'm going to forget what it stands for. The Software Levels of Security Assurance, I believe it is. Is it open source? Oh, I believe it is. Basically, a bunch of companies came together and figured out, okay, how do we define the integrity of the artifacts that are going through our stages? When we first build it, is that the same thing that we're deploying right at the end of the pipeline? So this is really important if you are shipping software and you're making it available to thousands of users, etc. There's been a lot of attacks on supply chains lately, which are able to modify the build at some point. So using the SALSA framework to go through and figure out, is the integrity of our packages intact as we go through the phases of the SDLC? Now that we've kind of built an application, it's running, we need to do some more testing on it because we're security. So Zap, I think most people know about Zap. It's one of the best dynamic application security testing tools, one of the flagship projects by OWASP, hugely popular, can be put into a pipeline, as we saw in the last talk here. Then we also need to worry about a couple other things. One, if we're using containers, then we need to check the base images of the containers themselves. Make sure that, we're not just rolling out full Ubuntu when we don't need it. Maybe there's a lighter package, like lighter, smaller container package image that we could use. So for that one, Sneak is probably my favorite. I wasn't able to find a fully 100% open source tool in this category, so that's the one I'm kind of going with, because it is free up to a certain point. And then for the infrastructure as code as well, so everything is as code now. So all of our deployment scripts and all the servers and containers we're going to be building are going to be written in Terraform files or CloudFormation or something of that nature. So we also want to check them and make sure that we haven't made any configuration issues, that we're not just opening up an S3 bucket to the world. We've configured logging and monitoring, etc. So Kix, which is by Checkmarx, but this is an open source project that they've released, will basically go through, works on GCP, AWS, and Azure, and will basically tell you these are the misconfigurations that you've made in your files. And then the final thing that we want to do is we managed our secrets, so hopefully nothing is flowing through now. Because we're using the secrets manager, we're not putting anything in plain text, but sometimes things just slip through. So we need to continually scan our source code in case secrets get out as well. Trufflehog, which is made by a couple of guys in New Zealand, so really big fan of that. Again, fully open source, can be pipelined in, will scan your code, identify any secrets that exist in there, and kind of report them back to you. All right, now we've actually got a built application. We're ready to deploy it. We deploy it onto some sort of cloud platform, most likely in these days. So what are all the things that we need to do after we've deployed the application as well? And this is where the kind of open source goes away, because the really big security players start operating in this space, and everything is super expensive and commercial. Luckily, there are some options for this. So that top box, we've got web application protection. So actually just putting those additional layers in to make sure that the application is secure. If we've put a SQL injection issue gets through the code and into the application, maybe there's a last line of defense that can protect against it. Application performance monitoring, which isn't strictly security, but the metrics that you get out of your performance monitoring are very much related to security. If we're seeing sudden spikes in usage or CPU usage, that could correlate to potential cyber threat. So I kind of always just include performance monitoring in these sorts of things. And then we finally got the cloud security posture management. So once we've deployed to AWS or something, we want to continually monitor that and make sure that the environment is secure. So a couple of projects on the left, which is OpenRASP, which is real-time application self-protection, which is like a little bot that sits in your application, tries to identify potential vulnerabilities and protect against them. That was created by the team at Beidou, but is 100% open source. We also have OWASP App Sensor, which is a framework for building these types of protections yourself. And they have a fully running version of it that you can kind of demo. So you can use that framework or the tool that they've built to include it into your app and use it kind of like a RASP, but also to provide some additional protections. Then we move into the right-hand side. Magpie was recently released a couple of years ago. To my knowledge, is one of the very few fully open source cloud security posture management tools. I haven't had a chance to play around with it myself, but it exists, it's there, it's open source, so if someone has used it, please hit me up later. It would be good to get your thoughts on it as well. And then the whole Elastic stack as a whole, like the Elk stack is great, but if you're going to be doing performance monitoring, again, this is a tool that you could use, and send all your applications metrics to that and start monitoring the performance of them. Once we kind of have all of the security information, if we're going to go open source, most likely, if you have a few different applications, you're going to be using multiple tools. So what we need to do is, one, have a centralized way to run these tools. That's where things like Glue and Secure Codebox come in. They're kind of the orchestration layer. So you can feed in a bunch of open source tools into them. So you're not adding multiple things in the pipeline. You're simply calling Glue, which has all of these tools attached in the back of it. So that's the orchestration. And then we also need kind of like a centralized view of everything that's going on. So that's where Defect Dojo comes in. You take all of the security issues that are identified by various different types of tooling. You have your SaaS, DAS, like IaaS stuff, and then you feed it into a centralized engine where you can get really nice visuals. You can understand which app is the worst, potentially which squad is the worst compared to others, things like that. So now we've kind of wrapped it all up. We've gone all the way from the left to the right. So we'll bring it all together into the little reminder of where we started from. So these are all of the different capabilities that we were trying to address through open source and OWASP projects. And then we have a view of where all the tools kind of fit into that process. I'll leave this one on for a moment because there's quite a lot on it. But I guess what I really wanted to just see is, can we do everything in secure SDLC without paying any vendors? So I think it can be done. It is obviously, it's going to be a challenge. I always stress that don't forget about engineering time. Just because you haven't paid for the tool doesn't mean it's free. Someone does need to stand up those servers. They need to run it. So you need to always balance that product cost versus the engineering cost. But if you want to kind of like test out, like, okay, do we need SaaS? Like, how important is that to the organization? Are we going to buy it and then realize it's not really adding value? Well, let's start with open source. Let's test it out. Let's prove that it's needed. And then we can formulate the business case to potentially move to a more commercial option. Or maybe we'll find it so great and we'll just continue using it. So a lot of information I kind of dumped onto you guys in the last 25 minutes. So what do we want to do? We'll come back to the overall purpose of this talk. The first one was there's too many things out there. Well, let's figure out what's important. Start with OWASP SAMM, like understand your organization, like where are we far behind, what do we actually need to do, what's going to give us the greatest bang for buck, essentially. Focusing on those and then slowly expand that program out. So I did say at the start of this talk that the guidance often talks about what, not how. That's not actually true. There is a ton of guidance on how to do things as well. You just have to look in the right places. The general cybersecurity frameworks usually have like an end note, which says software security, and it generally just tells you to put in a secure coding policy and you get that tick box and you're done. But if you look in the right areas, you start with OWASP, you start with the SAMM, you kind of begin to understand like what all of the things that we need to do. All of the projects and tools that I talked about, I'll put a list together and put that with the slide deck so you can kind of look at that as well. And then that everyone talks about DevSecOps now. So most important is try before you buy. Don't go into a meeting with a vendor and expect them to solve all your issues. Figure out which problem you're trying to solve, then figure out what category of tooling or process you need to solve that problem. Test it out. Use open source first. Figure out okay, is this adding value? And then go into those vendor discussions kind of armed with, one, a really good understanding of what the free tools offer, what additional capabilities you might need, so you can make a better purchasing decision, because budgets are constantly tight. AppSec is one of those spaces where budgets kind of float around development and security, sometimes get lost in that little black hole in the middle. So everything we need to do really needs to be focused on adding value back to the business. That is me. Here is a bunch of contact information if you have any questions or thoughts afterwards. And do we have a couple of minutes 2 minutes for questions, if anyone has any. All right.
You want? Nope. Okay. So,
Cool.
thank you very much, Raafey.
Thank you.